Hello, and welcome to this lesson on solving absolute value equations, which is a little break from what we've been doing. So far, the past bunch of lessons have been all about inequalities. This lesson is about equations, and this is going to actually tie us into the next lesson, which is absolute value inequalities. So it's important to understand this one to help us get a better footing on the next lesson. So the essential question says, how do I solve absolute value equations? Did you know that absolute value is a distance? You think of it more like as a number or an operation, but it's really a distance. It's always the distance a number is from zero. And since a distance is never negative, absolute value is never negative. Here's a little graphic I found on Google. So the absolute value of zero is zero. That's how far it is away from itself. 5, the number 5, is 5 units away from 0. That distance is 5. -3 is 3 units away from 0, so that's its absolute value. Its absolute value is the distance it is from 0, how far from 0 it is. Which is not what most students learn absolute value is. A lot of students just learn, whatever's on the inside of these little up and down bars, it makes it a positive number, which is for the most part true, but there's a little bit more to it than just make the number positive. So an absolute value equation is just an equation that contains an absolute value. An absolute value is the distance a number is from 0. And then this absolute deviation thing, this is kind of a specific example of a way the absolute value could be used in a problem or in real life, and we're going to get to this down in the applications. But the absolute value of the difference of x in a given value, so basically we'll be given a number and an absolute deviation, and we're just going to plug these two numbers into the formula, this exact formula right here, and then do the math, and we'll get ourselves an answer. Okay, so basically this is a formula. You do not have to remember that formula. It will be given to you, but you'll be using it a lot that you'll probably remember it. So let's start with the basics. Absolute value of some numbers. So the absolute value of 7. So whenever you're doing absolute value, you're almost always going to get two answers. So one answer for this, x could equal 7, because that's how far 7 is from 0. But also, we could get a -7. If we plugged in a -7 for x right here inside, the absolute value of -7 is also 7. So you're going to get a positive and a negative of that number. 7, absolute value of 7, absolute value of x is 7, gives us two possible solutions. My words are getting a little mixed up there. Hopefully we'll get better as the lesson continues. Letter B. Now think about this. What number, if you take the absolute value of, would you get -4? And a lot of students think, well, it's 4 and -4, but that's not true. The absolute value of 4 is a positive 4. The absolute value of -4 is a positive 4. There is no way that you can take the absolute value of something and get a negative answer. Absolute values will only ever give you positive answers. So this has no solution. There is no possible number you could plug in here for x that would make the absolute value of it equal a negative number. Okay, 2 for me, 2 for you. Go ahead and try letters C and D right now, please. All right. So letter C, x is 8 and -8. The absolute value of 8 is 8, and the absolute value of -8 is 8. Letter D is almost exactly like letter B. This one is also going to have no solution, because you cannot take the absolute value of anything and get a negative answer. Absolute values will only give you positive solutions. Okay, last of this type, and then we're going to get a little bit more complex. So go ahead and quickly throw down the solutions to these two problems. All right, first one, x is equal to 3 and negative 3. Second one, x will be equal to 15 and negative 15. Now I'm going to throw this out here because this is a symbol that you may see. I could write this or this a little bit simpler. Well, less symbols. So I could say x equal to a positive or a negative 15. This little a plus and a minus on top of each other. And you may have seen that symbol before and not quite sure what it meant. Positive 15, negative 15. This could also be used to say like plus or minus, up 15, down 15 sort of thing. And same thing here, x could equal, oopsie, positive and negative 3. So that's a way you could write, as long as it's the same number, you could write it like this. Just throwing it out there, it's something that you may see, you may use. That way you're aware of what it actually means. All right, so how do we solve an absolute value equation? Well, if this stuff right here, the stuff that I'm highlighting, was equal to 8, if this stuff in here was 8, then the absolute value of 8 is 8, and we'd be good. But also, if this junk here that I've highlighted was a negative 8, then absolute value of negative 8 is 8, and we'd also be good. So we actually are going to have two separate problems. One is where the x minus 3 is equal to 8. We're doing this case. How can I make this be 8? This is going to be 8, and we're going to figure it out. But also, how can I make this equal a negative 8? And so we're going to have two completely separate problems. One where this is equal to a positive 8, and one where this is set equal to a negative 8. And now we're just going to solve both of these equations separately. Minus 3 minus 3, x equals 5. Minus 3 minus 3, x equals negative 11. These are both solutions to this equation. And I can prove it to you. If we plugged in 5 here. Oh, now I'm realizing that I made a mistake. And you probably saw this earlier and going, what the heck is this guy doing? So I tried to get rid of my minus 3 by doing minus 3. That doesn't work. How about we do plus 3, plus 3? And I realized I made a mistake because if I plugged in 5 here, 5 minus 3 doesn't equal 8 like I thought it should. See, this is why you check your answers, folks. And let's see, that should be 11. And then when I do plus 3 and plus 3 here, now we're going to get a negative 5. So let's check that. If I plug in 11 for x, this inside of the absolute value will be 8, and the absolute value of 8 is 8. Okay, so that works now. But also, if I plug in the negative 5 from here, negative 5 minus 3 is negative 8. Absolute value of negative 8 is 8. So both these numbers I just showed you that they are solutions of this equation, that this makes this true. Okay, so our solutions were the numbers 11 and negative 5. Notice that it's not just the same number. It's not just like positive 5 and negative 5, or positive 11 and negative 11. Most of the time when you're doing a more complex equation, it will be two separate numbers. Okay, letter B. So I want to know what's it going to take to make the stuff inside this absolute value, this stuff here, equal to a positive 5 and equal to a negative 5. Again, because if this stuff was a positive 5, absolute value of 5 is 5. If this stuff in here was a negative 5, then the absolute value of negative 5 is 5. So I set up my two separate equations. One, I'm going to make this junk equal 5. The other, I'm going to make that junk equal a negative 5. I'm going to figure out what x value makes it a negative 5. And so I'm going to solve. So I'm going to start by adding 7 to both sides. 2x is equal to 12. Divide by 2 on both sides. And x equals 6. So if I plugged in 6 right here, make it a little small. There we go. If I plugged in 6 right here for x, 2 times 6 is 12. 12 minus 7 is 5. I made this 5, and the absolute value of 5 is 5. So this is one answer that makes this true. When I do that with negative 5, I'm going to get my other answer. So add 7, 2x equals 2, divide by 2, divide by 2, x equals 1. So if I plugged in a 1 for x, this will be negative 5, and the absolute value of negative 5 is 5, and the equation works out. So we have two separate answers, positive 6 and positive 1. All right, here's one for you to try. So why don't you go ahead and pause the video and try this one on your own right now. When you're ready to continue, hit play, and we'll go through it together. All right, so hopefully you separated it into two separate equations. One is where this stuff is equal to a positive, not 3, a positive 12. We want the absolute value of 12 is 12. And the other, we want the absolute value of negative 12 is 12. So this first one, we want 3x plus 3 to equal a 12. We want to make this junk positive 12. The second one, we want to make that stuff inside the absolute value bars a negative 12. And now we're going to solve both of these equations. So subtract 3 on both sides. 3x equals 9. Divide by 3 on both sides. X equals 3. Subtract 3 on both sides. 3x equals negative 15. Divide by 3 on both sides. And x equals negative 5. And if you're unsure of your math, you could always check it. I mean, I can check just by throwing numbers into my calculator quick. Here we go. So if I take clear, 3 times, I'm going to type in, I'm basically going to throw 3 in right here. 3 times 3 plus 3 is 12. And I know the absolute value of 12 is 12. So this one worked. On the other side, I want to show that when I plug in negative 5 for x, that this junk is a negative 12. So 3 times by negative 5 plus 3. Okay, it is negative 12, and the absolute value of negative 12 is 12. Rewriting an absolute value equation. So this is the next step of this process. This is a little bit more complex. You'll notice the problem's bigger. Instead of just being absolute value equals 4, I've got a 3 here and a minus 5 there. I've got some other stuff to worry about. So the first thing we're going to have to do is we need to actually get this piece by itself. I can't do what we were doing before, like separating into those two separate equations. I can't do that until that piece is by itself. So I want to get to a point where I have 2x minus 7 equals something. Now, if you look at this, this problem is very, very similar to the problem that. See, I want to get this piece by itself. 3 times something minus 5 equals 4. 3 times something minus 5 equals 4. I can solve these two equations the same. Like if I was looking at this, you'd say, well, what's the first thing you do? You would add 5 to both sides. Well, it's the same thing here. We're going to get rid of the add and subtract first. This piece cancels out. 3 times 2x minus 7 equals 9. Just like over here, I'd have 3x equals 9. I'm still trying to get this piece by itself, this piece. So I would divide by 3 on the right. I would divide by 3 on the left. And those 3's cancel, just like those cancel. And we'd get x equals 3. Well, on the left, we have, I'm just trying to move some stuff down, give myself a little bit more space. There we go. That stuff equals 3. Okay, so you have to isolate the absolute value. You have to get the absolute value by itself first. You cannot have anything else on the outside. And you are not allowed to distribute. That's a no-no. You can't do that because of these absolute value bars. You're not allowed to distribute it. And they're not exactly parentheses, but they're kind of like they're kind of grouping all this stuff together, but you're not allowed to break them apart. You can't distribute. Okay, now from here, we are going to separate this into two separate equations. Now, maybe you've noticed the pattern in the previous 3 problems. Basically, we're going to set this stuff equal to a positive 3, and we're going to set this stuff equal to a negative 3. Like we're going to change the sign of that number. So we're setting it equal to a positive 3, and we set it equal to a negative 3. And then we solve that equation. Add 7, 2x equals 10. Divide by 2 on both sides, and x equals 5. On the right-hand side, same steps. Add 7 to both sides. 2x equals 4. Divide by 2, and x equals 2. So these are the numbers. The only solutions, if we plug them in for x right here, it would make this whole left side equal 4. And I'm not going to show both. I'm going to show one of them. So if I took on my calculator, I'm going to do the inside of the absolute value first. So 2 times 5 minus 7 is 3. The absolute value of 3 is 3. In fact, there might even be an absolute value thing in here somewhere. Not there. Oh, there's absolute value. So if you hit math and go over to number, you can actually take the absolute value. So I could type this whole darn thing in. Let's see. Let's see if we can. 3 times the absolute value of, ooh, it even give us nice pretty bars. 2 times 5. Oopsie. It didn't put my parenthesis. There we go. Minus 7. Get out of the absolute value. Minus 5. So I have this whole thing typed in. 3 times the absolute value of 2 times 5 minus 7, closed absolute value, minus 5. That should equal 4. And it does. Now, somehow, oh, there we go. Now I can go through and I can actually, there we go. I can change this to a 2. I said I wasn't going to do it, but because I was able to type the whole thing in the calculator, I'm going to. I'm going to throw a 2 in for x. See, I just changed the 5 to a 2, and it equals 4. So I did show that both of these numbers make this left side equal 4. And this is the process. Get the absolute value by itself first, then separate it into the two separate equations. All right, another one. Now we're going to go a little bit faster because, well, we're a little bit more experienced, and we can. So if it helps you, think of that problem. So I'm going to start by subtracting 3 on both sides. I'm going to divide by 6 on both sides. I'm getting rid of the stuff on the outside of the absolute value. Now, we're going to separate. Now, make sure you understand that this is not a 1. This is not 1x plus 41. These are absolute value bars. Usually I try to make them really much taller, so they're definitely not 1s. All right, so we're going to take this and we're going to separate it. One side, we're going to make it equal to 3, and the other side, -3. So x plus 4 equals 3, and x plus 4 equals a -3. One is a +3, the other is a -3. And solve. Both of these take one step. We're going to subtract 4 on both sides. X equals -1. X equals -7. And there we have it. The whole thing start to finish. I isolated the absolute value by getting rid of the junk on the outside. You get rid of pluses using minuses. You get rid of multiplies using divides. Once it was by itself, we separated it into the 2 separate equations. One is where this stuff, I'm making it equal a +3, and one is where I make this stuff equal a -3. I solve both of those, and I find the solutions were when x is a -1 and where x is a -7. And now it's your turn. So I did 2, you do 1. Go ahead and pause the video, do this on your own right now. When you're ready to continue, hit play, and we'll go through it together. All right, hopefully you started by doing, that's a little big probably, -3 minus 3, 5 times 2x equals 20, divided by 5 on both sides, and absolute value of 2x equals 4. That's getting the absolute value by itself. So that's solving the first part of the equation. Now you take it and you want this stuff inside to be equal to a +4 and a -4. So 2x equals a +4 and 2x equals a -4. And you solve both of those. Divide by 2 on both sides, x equals 2. Divide by 2 on both sides, and x equals a -2. There you go. This is one of the few problems where we actually got the same number, just positive and negative. And that's what you should have got as well. So this 2 and -2 are the solutions to the original equation. Here are 3 more of this type before we move on to the next step of this problem. So go ahead and pause the video, try these 3 quickly. When you're ready to continue, hit play, and we'll go through it together. All right, I'm gonna make my marker a little smaller and zoom in. Let's see. There we go. So let's see here. This one, actually, I don't need to get rid of the stuff on the outside. There's no things on the outside. So this one, I'm going to start right away by setting the stuff equal to a +9 and a -9. A positive of this number and a negative of this number. So r minus 7 equals a +9, and r minus 7 equals a -9. To solve this equation, we need to add 7 to both sides, and r equals 16. Add 7 to both sides, and r equals a -2. This problem, we do need to get rid of stuff on the outside. So I'm going to start by subtracting 4.1. So 2s is equal to, I'm not sure what that is. I could do the math in my head probably quicker than typing calculator, 14.8. But doesn't hurt to check. There we go. And I'm going to divide by 2 on both sides to get rid of him on the outside. We get the absolute value of s is 7.4. for you people who like the calculator. There you go. And now, when I take this and I separate it into those two separate things, one is where this can be equal to a positive 7.4, and one where it's equal to a negative 7.4, which really is just s equals 7.4 and s is a negative 7.4. Since there's nothing else on the inside, it's just these two pieces. And there we have it. Okay, third one, the most complex of the three. I do have to get rid of junk on the outside, so I'm going to start by adding 5 to both sides. 4 times t plus 9 is 24. Divide by 4 on both sides, and absolute value of t plus 9 is 20. We can now take that and separate it into the two separate equations. One is where the absolute value is equal to a 20, and one is where the absolute value is equal to a negative 20. Or I should say the stuff inside the absolute value is 20, and the stuff inside the absolute value is a negative 20. So t plus 9 equals 20, and t plus 9 equals a negative 20. And we solve. Minus 9 minus 9, t equals 11. Minus 9 minus 9, t equals negative 29. So there's all three. Decide if an equation has no solutions. So it is possible, as we saw in the beginning of the problem, let me find the right page here. We saw right here that this problem had no solution because absolute value does not give you a negative answer. Absolute value cannot equal a negative number. Absolute values only give positive answers, as here. Now, the thing inside the absolute value bars, that can be negative. The absolute value of negative 8 is 8. You're allowed to have a negative on the inside. What you're not allowed is an absolute value to equal a negative number. So that's what we're going to be looking for to decide whether the problems that we're going to be doing now have a solution or not. So I'm looking at this. We can't determine right now whether this has no solution or not because the absolute value is not by itself. We have to get there. So I'm going to start by subtracting 6 on both sides. Now I can decide whether this has a solution or not, whether I keep going or I stop here. Absolute value equals a negative? That's not allowed. There's no way. There's nothing I can plug in here to make this junk equal a negative 8. This problem has no solution. And we'd stop right there. That's it. That's done. Does this have a solution? Well, let's see. If we add 9 to both sides, absolute value of 2x plus 4 equals 14, this would have a solution. We could keep going because now the absolute value is equaling a positive number, which is what we want. I'm not going to go through the whole process, but just to show this, we would want this stuff to equal a positive 14 and the stuff to equal a negative 14. I'm just going to set up the equations and then move on to the next problem. So you'd have 2x plus 4 equals a positive 14 and a 2x plus 4 equals a negative 14. Okay, and you'd solve both of those separately and get your solutions. But this right now is basically just deciding whether it does have a solution or not. So, could you pause the video and do as much as you need to do to determine whether this does have an answer or if it doesn't have an answer? So go ahead and do that now. Okay, so this does not have a solution because when you subtract 8 on both sides, in order to get the absolute value by itself. This cancels. Absolute value of 2m minus 3 is equal to negative 1. That is not allowed. You cannot have absolute value equaling a negative number. That is not allowed. This has no solution. Okay. Solve the equation if possible. So that's what I'd like you to do. For these two, pause the video and try to solve the equation if you can. So meaning if you get a solution, if you get the whole way down to x equals 5 and x equals whatever, great. If you get to a point where you go, I can't solve this, this has no solution, awesome. So go ahead and pause the video and do these two right now. All right, here, so let's see. Well, let's just do the first one first, I guess. I'm going to subtract 4 on both sides. I'm trying to get the absolute value by itself. 2m minus 5 equals negative 2. When I divide by 2 on both sides, we get absolute value of m minus 5 equals negative 1, and this has no solution. Absolute value cannot equal a negative number. No solution. That's my answer, is that there is no answer here. Number 6, we're going to add 7 to both sides, and that gives us negative 3. Absolute value n plus 2 is equal to negative 3. When I divide by negative 3 on both sides, absolute value of n plus 2 is equal to a positive 1. We can continue. Absolute value equals a positive 1. So then we're going to break this down and say, okay, I want this stuff to equal a 1 and equal a negative 1. So I want the stuff inside the absolute value bars to equal 1 and the stuff on the inside to equal a negative 1. And we solve. N equals negative 1. N equals negative 3. Now, absolute deviation. So, if the absolute deviation from 9 is 5, what values satisfy this requirement? So this is that formula we had way back up in the vocabulary. It looked like this. Absolute value of x minus the given number is equal to absolute deviation. Now we could take this problem and take the values they've given us and just throw them right in here and we would get an answer. So, but it does take a little bit of understanding the problem. The words themselves are a little confusing. So if the absolute deviation from 9 is my given number, we're deviating from 9. Do you know what the word deviation means? Or if it means to deviate, it means to change. So we are changing from the number 9, and it says here the absolute deviation is 5. We are deviating 5. So check this out. If I plug in the values, from 9, we are deviating 5. We can then solve that little equation. I want this to equal the stuff inside to be a positive 5 and the stuff to equal a negative 5. And we solve. Adding 9 on both sides, x equals 14. Adding 9 on both sides, x equals 4. But there's an easier way of doing this, or I should say there's a different way of doing this. It's good to know the formula way. There's times where the formula way is the best way, but there's also times where with a little problem solving we can do it a different way. Here's what it's saying. So imagine you have yourself a number line. And we're deviating from the number 9. Remember, that was our given number. the absolute deviation from 9 is 5, meaning I'm going to deviate 5 units bigger and 5 units smaller than 9. Oopsie. My brain was working ahead of itself. So I'm deviating from the number 9 5 units up and 5 units down. And guess where that lands me? At 14 and 4. Those were the two solutions we came up with. That's really what this problem is doing. If the absolute deviation from 9 is 5, up 5, down 5, what values satisfy this requirement? Well, it is 14 and it is 4. If the absolute deviation from -2, so I'm starting from -2, and the deviation is 6.1, I'm going up 6.1 and I'm going down 6.1. What values satisfy this requirement? Now, I'm still going to do the equation way because that's the way that we're trying to practice. We're practicing absolute deviation with a formula. These types of absolute deviation problems are just here to give us a type of application. So x minus the given number is -2. Notice how I have minus -2. It's minus from the equation, and the given number is a -2. And the deviation is 6.1. Now I'm going to change this minus -2 thing here into a plus. And now we solve. I want this junk inside to be equal to a positive 6.1, and I want the junk inside to be equal to a negative 6.1. So we make that happen. And we solve. -2 on both sides, x equals 4.1. -2 on both sides, x equals -8.1. And guess what? From -2, if I go up by 6.1 units, I'm at positive 4.1. But if I'm at -2 and I go down by 6.1 units, I'm at -8.1. So this is the expected result from that. We're practicing using the formula and using the equation. We're practicing solving the equation way, but this is a good mental check that you're doing the right thing. Okay, letter C. I want you to do this using the formula way. In fact, I'll write down the formula for you. X minus the given number equals absolute deviation. So there's your formula. Okay, I want you to do this. Now you can check using the little number line graph thing. Okay, so pause the video, go ahead and do this right now. When you're ready to continue, hit play, and we'll go through it together. All right, so let's see. Absolute value of x minus, we're deviating from -8, and the deviation is 2. Absolute deviation is 2. I'm going to simplify minus a -8 into a +8. And so we want this junk to equal a +2 and this junk to equal a -2. So x plus 8 equals 2, and x plus 8 is a -2. And we solve. X equals -6, and x equals -10. If I'm checking this on my number line method, from -8, I'm deviating 2 up and 2 down. Well, I can see that this looks like it should work. I mean, to -6 and -10, 1, 2 up, 1, 2 down. So there's my mental check of my math. I think this is the last problem. Yeah, it is. If a pencil is normally 0.3 inches in diameter, but has an allowed deviation, read that as absolute deviation, of 0.5 inches, what is the range of pencils or diameters a pencil could have? So basically, tell me what's the biggest and smallest pencils you're allowed to have. Go ahead and do the problem right now. Okay, so absolute value, x minus given, equals absolute deviation. That's our formula. So what is the given number? What is the normal number? What is the allowed number? Well, it's normally that. That's our given number, 0.3. And it has a deviation of 0.05. That's me plugging the numbers into the formula. And then we're going to take this and separate. We want this stuff to be a positive 0.05 and this stuff to be a negative 0.05. So we make it happen. And x minus 0.3 is a negative 0.05. We're going to add 0.3 to both sides. And x is equal to, actually I could do the math in my head, 0.35. And when I add 0.3 to both sides here, x is equal to, pretty sure it's going to be 2.5, but or 0.25. Let's see, negative 0.05 plus 0.3. Yeah. So those are our solutions. Now our check. If you're doing the mental check, if you're doing a little graph thing, from 0.3, it's normally 0.3. That's the middle number. We're allowed to deviate 0.05 up and 0.05 down. That means getting bigger and getting smaller. And that's exactly what we have. Summary. How do you solve absolute value equations? Go ahead and answer this question right now. Put down some thoughts. You can make a list or a graph or something. Put down anything you want. How do you solve absolute value equations? If I had to come up with some steps, I would say things like, well, I'm gonna flip through some pages here. So things like, here. First thing you got to do is you've got to get the stuff on the outside of the absolute value gone. You have to get the absolute value by itself first, like here or here. That's the first thing you do. Then you set the stuff inside the absolute value bars equal to positive of that number and the negative of that number. And then you solve both of those equations separately and get your two answers. But you have to watch out for when you get the absolute value by itself, if it's set equal to a negative, like here, absolute value is equaling a -1, that's not allowed because absolute value can never give you a negative answer. So you have no solution. And I'm pretty sure that's it. I mean, those are the steps that I would go through in my head as I'm solving an absolute value equation. And I'll tell you very much, the next lesson, solving absolute value inequalities, is almost this exact same thing, with the difference of, well, we're going to be graphing the inequalities on a number line. We have to worry about what happens when we divide by a negative, like right here. We divided by -3, but because it was an equation, we didn't have to worry about it. With an inequality, we have to worry about the direction of the inequality changing. And that's pretty much it. Okay, so thank you so much for watching, and until next time, toodles.